Welcome back to Refreshing Careers. Today we are going to do the part 6 of linear programming. This is a topic in the subject operations research. And today's question is, a marketing manager wishes to allocate the annual advertising budget of rupees 20,000 in two medias A and B. The unit cost of a message in media A is rupees 1,000 and in media B is rupees 1,500. Media A is a monthly magazine and not more than one insertion is desired in the issue. At least 5 messages should appear in media B. The expected effective audience for one message in media A is rupees 40,000 and for media B is rupees 50,000. Formulate an LPP and solve. Here they are asking us to solve. So we'll solve using the graphical method. And let's formulate an LPP. Like how we used to do previously, the previous parts, like how we have done, same way we have to form LPP, and like how we did in the previous part, we're going to solve it using the graphical method. Okay, now here what is happening in the question is, there's a marketing manager. Okay, that marketing manager has been given a budget of 20,000. Okay, he can spend, maximum he can spend is 20,000, or he can spend less than 20,000, right? Can spend, budget is 20,000. Whenever you are being given a budget, you are expected to spend either that amount or less than that amount. So your maximum amount that you are going to get from your company is rupees 20,000. This 20,000 he is going to spend in two media, that is media A and media B. He has to divide this 20,000 or whatever amount it is that he has to invest in. He has to put this amount in media A and media B. Okay, media A and media B, can understand it as magazine A and magazine B. So basically there are two magazines. Okay, magazine A and magazine B. In magazine A and magazine B, in both these things, there are some messages that will be published. By messages we mean articles. Okay, there are some articles being published in media A and media B, and the unit cost of one article or one message in magazine A is rupees 1,000, and in media B the cost of one message or one article is rupees 1,500. So what they are saying is, there are two magazines, magazine A, magazine B. Okay, media A or magazine A or media B or magazine B. The cost of one message in magazine A is rupees 1,000. That means for every message that you print in the magazine, you have to spend 1,000 rupees. And in case of B, it is 1,500 rupees. Cost of one message. Okay, we're speaking of the cost of one message in this particular magazine. Now, the next thing that they said is, I'll come to this part later. The expected effective audience for one message in media A is rupees 40,000 and for media B is rupees 50,000. Now, if I am going to publish one message, in magazine A, the profit that I would be making, okay, the profit or the expected effective audience, okay, now or nothing but it's another way you can say that this is profit. The profit that you will be making is 40,000 per message, okay, in magazine A. In case of magazine B, for one message you will be making 50,000 rupees as profit. Okay, so the cost that you will be incurring for one message is 1,000 and the profit that you will be making is 40,000 for one message in case of magazine A. In case of magazine B, you will be incurring a cost of rupees 1,500 per message, and in case of magazine B, you will be getting a profit of 50,000. Okay, that is what, this is the summary. Okay, I've just written it down so that it's little easier to understand. The cost per message is this much, the profit per message is this much. Now we need to find out how many messages you need to publish in magazine A and how many messages you need to publish in magazine B. Okay, by making sure that all the constraints, the conditions that have been put, by meeting all the conditions that have been put, so you have to make sure that an optimal solution is found. And here what you need to find? Here we need to find how many messages have to be put in magazine A and how many messages have to be put in magazine B, so that we get the maximum profit. Our aim is that we get maximum profit. Okay, our aim is to get maximum profit, and we know that per message what is the amount. Okay, we know that per message what is the profit that we are getting. Okay, per message profit we know. The thing which we don't know is how many messages are there. Okay, this is same like how previously we were doing, just the numbers are big in this question, but the logic is same. Okay, now the point that we missed is here. Media A is a monthly magazine and not more than one insertion is desired in the issue. Now media is a monthly magazine. Okay, it's a magazine and not more than one insertion. One insertion means one message is desired in the issue. That means they're saying that in this media A, they do not want more than one message or do not want more than one insertion. That means in this A, in the magazine A, you can have either one message or zero messages. That is, you can have one message or no message. It should not be more than one. That is what they are trying to say. And the next condition that they have kept is, the next restriction or the next constraint is, at least 5 messages should appear in media B. Okay, in media B, at least 5 messages should appear. That is, there should be at least 5 messages or more than 5 messages. Okay, there should be at least 5 or more than 5. That's what they mean by this sentence. So now the first thing which we need to do is to find out our objective function. Okay, here our objective is to maximize profit. Okay, our objective is to maximize profit. Okay, the objective is to maximize the reach of the audience. Okay, maximize the reach of the audience, or to maximize the reach of the audience, we are going to make more money. So it indirectly means we are going to make profits. Let us assume that the total profit or the total reach, you can put it as total reach or total profit, is Z. I am assuming this to be as Z. So the total profit will be equal to reach of media A plus reach of media B. The total profit will be equal to reach of media A plus reach of media B. The reach can be replaced by profit for better understanding. Total profit will be equal to profit made out of magazine A plus profit made out of magazine B. Okay, now what is the profit made out of magazine A? That can be represented as this. The profit made out of magazine A will be total messages printed in magazine A multiplied by the profit per message in magazine A. Similarly, the profit in magazine B would be the total messages that is printed in magazine B into the profit per message in magazine B. Now in the question they have not given us what are the total messages that's printed in magazine A and what are the total messages printed in magazine B. So these two things are the unknown variables. We don't know the total messages in both the magazines. So we need to assume that to be x1 and x2. So x1 will be total messages in media. I am going to assume that x1 is total messages in media A, and I assume x2 to be the total messages in media B. And x1 and x2 are the decision variables. X1 and x2 are the decision variables. We assume that. Okay, we assume that. Okay, so we are assuming that x1 and x2 are this. Again, these are decision variables. Now we are going to replace it as so that we get a linear equation. Total profit is Z, because we assumed here, is equal to x1. x1 is the total messages in media A into profit per message in A, that I have written here 40,000. It's over here 40,000 to 40,000 plus total messages in media B, total messages in total messages in magazine B, that is x2. We assumed it to be x2, that is x2, into profit per message in media B. Profit per message is is mentioned here is 50,000. Profit per message in media B is rupees 50,000. So we are going to write it as 50,000. So total profit will be equal to x1 into 40,000 plus x2 into 50,000. Now let's go to the constraint. The first constraint is with regard to 20,000. They said that our budget is 20,000. They said that budget is 20,000. So you can spend 20,000 or less than 20,000. It should not be greater than 20,000. Okay, whatever you are spending, you can spend an amount equal to 20,000 or less than 20,000. Okay, it should not cross 20,000 at any cost, because that is the budget being provided to you. Okay, so this has to be kept in mind. And the next thing which we are being told is the unit cost of message. The cost of per message in magazine A is 1,000. The cost of per message in magazine B is 1,500. Okay, so this is one constraint with regards to cost. Okay, cost constraint. The cost constraint is saying that 1,000 is the cost, right? 1,000 is the cost for x1 messages. 1,000 is the cost for x1 messages. This plus 1,500. 1,500 is the cost for x2 messages. This should be, I'll write it again, x2 messages. This should be less than or equal to 20,000. This should be less than or equal to 20,000. This is our first constraint. Okay, this is our first constraint. So what is happening here? This is the constraint with regards to cost. They have said that cost has to be 20,000 or less than 20,000. That's why I use the less than symbol and equal to sign. Okay, it has to be less than, cost has to be less than or equal to 20,000. And then they have said that the cost for x1 units, the cost for one message is 1,000. So the cost for x1 units will be, x1 messages or x1 units will be how much? Will be 1,000 into x1. The cost of one message in case of media B is 1,500. Okay, but we don't know how many media B's are there. Okay, so let us assume that x2 messages are being printed. So number of messages, that's x2 into 1,500 would give you the total cost for media B, or in case of magazine B, for printing the messages. So this is the total cost incurred in case of magazine B. This is the total cost incurred in case of magazine A, and this entire thing will be either equal to 20,000 or less than 20,000. This is the first constraint. Now the second constraint. The second constraint is with regards to the number of messages. They have said that media is a monthly magazine and not more than one insertion is desired in the issue. That is, they said that it should be not more than one. It should not be more than one. So your x1, that is, your x1 is what? Number of messages, right? Here I have written that. See, we have assumed that x1 is the total messages in media, and here they have told that the messages, that is insertion of more than one, is not desired. Okay, not more than one insertion is desired. So x1 cannot be more than 1. It has to be less than 1 or equal to 1. It has to be less than 1 or equal to 1. It has to be less than 1 or it has to be equal to 1. Because they said that number of messages in media A should not be less than or equal to 1. Number of messages in media is represented by x1. That's why I written it in this way. And the second thing what they have told is with regards to this, with regards to media B, they have said that at least 5 messages should appear in media B. That is, there should be 5 messages or more than 5 messages. That's what they said. At least 5 messages should appear in media B. And number of messages is represented by x2. Okay, number of messages in media B is represented by x2, and this x2 should be at least 5. Okay, so x2, your x2 should be at least 5. That is, it can be equal to 5 or it can be greater than 5. x2 can be greater than 5 or it can be equal to 5. Okay, that's what this says. So these are the three. So these are the three constraints. The next is non-negativity condition. This will remain same. Your decision variables, that is x1 and x2, your decision variables cannot be negative. It cannot be negative. It cannot be negative. It can be positive or it can be 0. That is, either there can be no messages, or there can be one message, two messages, or any positive numerical. Numerical can be the number of messages, but you cannot say there's -1 message, -10 message, right? That's why this non-negativity condition comes into picture, and both x1 and x2 will not be negative. That's why you're representing it in this way. Now the next. Now to represent what all we solved, we are representing it here. That is, your maximum z will be equal to x1 into 40,000 plus x2 into 50,000, subject to 1, 2, 3, these three constraints. Your x1 should be less than equal to 1, your x2 has to be greater than equal to 5, and this is 1000 x1 plus 1500 x2 has to be less than equal to 20,000, and this is a non-negativity condition. Okay, I've just written it in one page. Now we need to solve this. Okay, the first equation we'll be taking is this: 1000 x1. Okay, 1000 x1 plus 1500 x2 is equal to 20,000. Okay, we have written it as equal to because we are going to find out graph that we are going to find out points that we can plot in this graph. For that purpose, I need a linear equation. That's why I am replacing less than. That's why I am replacing less than equal to sign with equal to sign just for solving this. Okay, just for solving, I'm going to do it like this. Now let's assume that let x1 be equal to 0. Okay, I'm assuming x1 to be equal to 0. Then what will happen? 1000 into 0 is 0. So what will be left? 1500 x2 is equal to 20,000. 1500 x2 is equal to 20,000. Okay, is equal to 20,000. So x2 will be equal to 20,000 divided by 1500. That would be equal to 13.33. Okay, the next will be assuming x2 to be 0. x2 to be 0, and we'll be solving in the similar way. Let x2 be equal to 0. Then what will happen? If x2 is 0, 1500 to 0 is 0. So it will be x1. So 1000 x1 will be equal to 20,000. And x1 will be equal to 20,000 divided by 1000, that is equal to 20. Okay, so the points here are, now let's assume x1 to be x. Okay, let's assume x1 to be x in the graph, and your x2 to be y. Okay, so I'm taking x1 as x and x2 as y. So here your x1 is what? You have considered x1 to be 0. So your x1 you will be writing first 0, comma, what have you considered x2? x2 we have found it out to be 13.33. So write it down, 13.33. So this is your first point, 0, 13.33. Now the second point is x1 is equal to 20. Okay, x1 is 20, x2 is 0. Your x1 is 20, this is what I have found, your x2 is 0. Okay, so these are the 2 points which are going to plot over here and then join the lines. This is the origin. Let me make the graph ready. Before we go to the graph, let's even solve these two things. Okay, we have solved the constraint number 1. We have found out the 2 points that we want. Now let's do the same for constraint 2 and constraint 3. The second constraint is x1 is equal to 1. Taking x1 is equal to 1. Next thing that they're saying is x2 is equal to 5. x2 is equal to 5. Okay, now this is the second constraint and this is the third constraint. I put it as equal to. Here also I put it as equal to for the same reason as I told before. For the purpose of plotting it in graph, we are making it as equal to. This also is a linear equation. This also is a linear equation. Here your x, this can also be written in this way. x1 plus 0 x2 is equal to 1. So it's if anyone is getting confused that how to plot this, it will be just a straight line. This also will be a straight line. Okay, this and this is nothing but it's one and the same, right? 0 x2 is nothing but 0. So now we have to plot this. If anyone is getting confused, for them to understand, I just wrote it like this. The presence, if you write a 0 x2 or you don't write x2 is one and the same. So you don't think that just because you have not written x2 or it's not a linear equation. This also is a linear equation. This also is a linear equation. I'm rubbing this. Okay, so these two also are your linear equation. Now let us plot x1 is equal to 1 first, because this is the easiest. Plotting these two will be very easy. This is x1 is equal to 1. Which is x1? x1 is your x-axis, right? x1 is your x-axis and this is your 1. Okay, so this is the graph. The graph is ready. Here x1 is equal to 1. This is the first equation which I am going to plot in the graph. x1 is nothing but your x-axis. x1 is equal to 1. That is 1 will be in between 0 and 2. That is in the center point. So from here we need to draw a straight line. So here we need to draw a straight line. Okay, I have roughly done this. Let this be purple. Okay, so your purple line represents x1 is equal to 1. Okay, see x1 is equal to 1, that is 1 will come between 0 and 2. Roughly I have plotted it between this, that is will be the center point. So this straight line I will be drawing. So it's going to be just a straight line. Okay, now the next equation is x2 is equal to 5. This will be a horizontal line. This is a vertical line, this will be a horizontal line. Your x2 is nothing but your y. In this graph it is y. Your x2 is nothing but y. So x2 is equal to 5. So where is 5? 5 will be in between 4 and 6. 5 will be in between 4 and 6. Let's take another color. Let this be dark blue. Okay, so dark blue is x2 is equal to 5. This is your x2. Okay, so x2 is equal to 5. So try to put it in the center. You can use the actual graph to get more accuracy. Okay, here x2 is equal to 5, so it will be between 4 and 6. That's why I have drawn it here. So x2 is equal to 5. Here x1 is equal to 1. These two I have drawn. The next thing which I will be drawing is this. That's the first equation. 1000 x1 plus 5, 1500 x2 is equal to 20,000. The first point that we found was 0, 13.33. That is 0 will be your x1, your x2 is this. So 0 on x1. So this is x1. This is x1, 0 on x1 is this, and 13.33 on your x2. 13.33 on your x2. It will be somewhere here, right? It will be somewhere here. So the point will be on x1 it is 0, on the y-axis it is 13.33. So roughly the point will be here. Let me just mark it. For this one, let us take yellow color. Okay, let us take yellow color for this. Roughly I am marking it. This is the point. Now the other point is 20, 0. 20 on your x-axis, 0 on the y-axis. So 20 on the x-axis, that is here, 0 on the y-axis. This is y-axis, 0 on the y-axis is this. 20 on the x-axis, this is x-axis, 20 on the x-axis, this. So this will be your next point. So I'll mark here also. Now I need to draw a straight line. Okay, so joining these 2 points. Okay, joining these 2 points. So this is my constraint. So this is my first constraint. So yellow is this constraint, the first constraint. The second constraint x1 is equal to 1 is represented by purple. Your third constraint that x2 is equal to 5 is represented by blue. Okay, represented by blue. Now we need to see whether which is less than or equal to symbol. That is, here I replace it by equal to, but in reality what is the symbol? The symbol was less than or equal to. It was less than or equal to. Since it is less than or equal to, we need to find out what was the sign over there. The sign was of that of less than or equal to. That is, for this yellow constraint is nothing but this particular equation. Okay, this particular equation is represented by the yellow constraint. For this particular equation, we saw over here that the sign is less than or equal to, and whenever the sign is less than or equal to, we have to shade towards the origin. So now we need to shade. So let us shade towards the origin. So it will be proper shading, okay, from this line, towards the origin. So this is the shaded portion. Okay, so this portion will be shaded. Why am I shading it towards the origin? From the line I am shading it towards the origin because they had used the less than sign. They had used the less than equal to sign. Whenever the less than symbol is used, we are going to shade it inwards. Shading inwards means shading towards the origin. Shading towards the origin from the line. Wherever the line is, whenever we shade towards the origin, that is happening because there is less than sign. Okay, there is less than to or equal to sign. Now let's see the second constraint. Your second constraint is x1 is equal to 1, which is represented by the purple line. x1 is equal to 1 represented by the purple line. So what is the sign used here? Okay, this is x1 is equal to 1. We have represented here that is equal to because we are converting it into a linear equation just to solve the graph. But in reality, what was the sign? In reality, the sign was less than or equal to, and whenever there is less than, what we should do? We should shade it inwards. We should shade it inwards towards the origin. That means even the purple one, we have to shade it inwards. So I'll be shading this inwards. Okay, I'm shading this inwards. So now we have found out that the area to be considered would be somewhere in this region. Okay, would be somewhere in this region. That is somewhere from this 13.33 to 0 to this particular point to this point. So this region which I am showing now, some part of this region or some point in this region would be our optimal point. Okay, but we have not yet finished the question because we have to shade with respect to this line also. Okay, blue line is with respect to this linear equation, that is x2 is equal to 5. Okay, here we have taken it as equal to, we have taken it as equal to because we wanted to convert it into a linear equation. But in reality, what was it? In reality, it was greater than or equal to sign. Now whenever it is greater than, it has to be away from the origin. It should not be towards the origin, it has to be away from the origin. Okay, now when you are saying it has to be away from the origin, the region that you would be shading is, dark blue is the color I took, away from the origin. That would be towards this side. This is the region away from the origin. Okay, it would be like this entire thing. Okay, it's very difficult to shade it. This entire region, like, which is away from the origin. Okay, I'm just roughly doing. Okay, so this entire region has to be shaded. Okay, it will take time, that's why I'm not shading it fully, but please understand that I'm trying to shade this entire region above the axis. So basically this was our line and we have shaded the region above the line. So now which is our common point? After doing everything, what did we find out? We found out a common point. That is, let me name it. Point number, the first point is this particular point. This is the first point, this is the second point, this is the third point, and this is the fourth point. These are the 4 points. Okay, these are the 4 points. And let us plot it. Let us plot this thing. Now let me mark it first. Let me give it names A, B, C, D. Okay, so I have marked the feasible region here. The feasible region is A, B, C, D. And how did I get this region? This is the common shaded portion. So when I shaded, this is the portion where I have all the three have come together. So that portion is my feasible region, A, B, C, D. So one point in this feasible region would be the optimal solution, would give us the answer to the question. That would be the optimal solution. So let us write down what is A, B, C, D. Okay, so I have written down here our feasible region is A, B, C, D, and what is point A. Okay, what is point A? Point A is 0, 13.33. This is what we had plotted. Point A is what we had plotted. That is here we had plotted. That's how I know it is 0, 13.33, because we really plotted this, right? So roughly we had marked this point as 13.33 and this we marked. So this is A is nothing but 0, 13.33. Next, let's see what is our C. Our C is, this is on this particular line. This line was representing 1, right? So this is 1. So this is 1 over here, and over here it is 5, because you have marked it like that. So your C will be 1, 5. Your D also is easy, because here on the x-axis coming correctly over here. So this is 0 and here it is 5. So this is 0, 5. And next comes your B. Your B, I have taken it as 1, 12. Okay, 1, 12. This may not be exactly 12. I have taken it as 12 because in what I have done over here, I am getting it as 12. But when you do it in a proper graph, it can be little around this value. It can be little down, little above. Okay, I am taking approximately 12. Okay. You can use a proper graph sheet to get the exact figures. You can use a proper graph sheet and then you will be getting the exact figures, and it will be like more easier to understand what we're doing. Okay, so these are the points that I have taken. A, B, C, D are the points of the optimal region. Okay, so now we have to find the points which is going to maximize our profits. Okay, we are going to find what is going to maximize our profit, for which you have to refer to this equation. So this equation is that of maximum. So whenever there is a case of maximum, we have to take the value that is going to give us a maximum digit. Let me write down this equation over there. X is equal to x1 into 40,000 plus x2 into 50,000. Z is equal to x1 into 40,000 plus x2 into 50,000. Okay, so your x1 are the first values, x2 are the second values. So we need to replace this x1 and x2 by such a value that you will get the maximum z. Your z has to be the maximum. Such a value you need to find. So by looking at it, it's very clear that the point C and D, If you replace this by 1, this by 5, you will not get a value as high as you would get in case of A and B. By just looking at it, prima facie, I am just saying. Okay, because it's understood, right? Because 1 and 12, 0 and 13.33 is much higher than 1 comma 5. So if you replace your x1 with 1, you replace the x2 with 5, obviously your answer will be less than what you will get in case of these two. So it's better not to waste your time trying it out. It is understood. But if you want, you can once solve it and see. It won't give you the maximum answer. You'll get maximum either in A or in B. Now same goes for D. If you see it only, you can make out, right? If this is replaced by 0, it will become like 0 here plus 5 into 50,000. It will be like 250. So this answer will be obviously more than that. So let us not waste our time taking points C and D. So answer will be either A or B. So let us try out both. Let me try out B first. Okay, this 12 is roughly I've taken. It's a value little bit, it will be below 12 or above 12. I've roughly taken it as 12. Okay, can use a proper graph to get the exact value for this. I'll be taking this as 12 now. Your x1 is 1. So x1 is equal to 1. So 1 into 40,000 is 40,000. Plus your x2 is what? Your x2 will be 12. That is 12 into 50,000. 12 into 50,000 will be equal to 6 lakh. Will be equal to 6 lakh. So if you take B, your answer will be 6,40,000. The answer will be, let me rub and write it. So in case of B, your answer will be 6 lakh. Answer will be 6,40,000 is your answer. That is in case of B. Now let me see what will be the answer if I take A as the optimal solution. Okay, 0. x1 is equal to 0. So 0 and 40,000 is 0. Plus x2. x2 is 13.33 into 50,000. Let us solve this. You can use a calculator for the same. 13.33 into 50,000. That will give you 6,66,500. That will give you 6,66,500. That means the optimal solution, either you'll get this or you'll get 6,66,666.6, and I'll show you how we are getting it like that. If you remember, if you take this as 13.33, okay, if you round it off and if you take it as 13.33 and you multiply it with 50,000, let me do and show. 13.33 into 50,000, you will get an answer of 6,66,500. That is what this is. 6,66,500. How do you get this one is, see, it's not 13.33. It is 13.33333333. Okay, it is 13.33. I just rounded it off and I took it as 13.33. So I think it will be easier for us to understand. It is nothing but 40 by 3. 13.33 is nothing but 40 divided by 3. Okay, that is what this is. You can take it as 40 by 3, or you can take it as 13.333, or else you can write it as 13.33. It's up to you. Okay, this one, when you multiply this with 50,000, you'll get this answer. You'll get 6,66,66.67. That's how you get this answer. So whatever answer, whether it is this or this is greater than what I'm getting in case of B. That's why my optimal solution will be this. That is 0.13.33. That is x1 is equal to 0. So your final answer is your solution. Your solution is that x1 is equal to 0 and your x2 is equal to 6,66,666.67, or this or the one I told you. Sorry, not your x2. Sorry, I mean your z. Okay, x2 is not this. your x2 will be equal to 13.33. okay, x2 will be equal to 13.33. x2 will be equal to 13.33, and your final answer, your z will be equal to this. Your z is equal to 6,66,667.67, and x1 is equal to 0, x2 is equal to 13.33. okay, this is your feasible region. This is your final solution. You found out what is x1, you found out what is x2, and you even found out what's the maximum profit that you are going to get, which is equal to rupees this much. Okay, thank you so much. Please do like and subscribe the video and the channel. Thank you so much.